Good morning, students. Today we discuss about the enveloping cone. First of all, we have to understanding the what is the definition of enveloping cone. Here listen carefully. Let S be a surface and P be any point not on the surface. Right here, listen carefully. S be any surface, P be any point but not on the surface. The set of all tangent lines to the surface and passing through the fixed point, that is a P, form a cone with a vertex. Then it is form a cone. This cone is called an enveloping cone. Right? Here listen, I will explain the definition once again. Here, S be any surface, S be any surface, P be any point, it is a P be any point, but P is not on the surface. Draw the tangent lines to the surface from a point. It form a cone. This cone is called enveloping cone or tangent cone. Right here, listen, what is the tangent line? Here, what is the tangent line? It is a surface. Draw a line touching the surface. Draw a line touching the surface is called tangent line. It is called intersect the line. It is called intersect the line, but it is not a tangent line. Not a tangent line. Right? What is a tangent line? Draw the line to the surface. It touches the surface is called tangent line. Right? Okay. Right? What is the definition of enveloping cone? S be any surface, P be any point not on the surface. Draw a tangent lines to the surface from a point. It form a cone. This cone is called enveloping cone. Right. Next, what is the condition? What is the condition to the tangent line? If it is any quadratic equation, that is a ax square, that is ax square plus bx plus c equal to 0. It is a tangent line. For example, it is a tangent line. Then the discriminant, it must be equal to 0. Discriminant formula, b square minus 4ac equal to 0. This is a condition for the tangent line. Okay, right. Next we go to the theorem. Here listen, it is a very, very important theorem. Right, the enveloping cone of the sphere x square plus y square plus z square equal to a square. This is a sphere whose center is 0, 0, 0, and vertex is given, that is x1, y1, z1 is x into x1 whole plus y into y1 plus z into z1 minus a square whole square equal to x square plus y square plus z square minus a square into x1 square plus y1 square plus z1 square minus a square. This is the statement of the theorem. What is the statement of theorem? Enveloping cone of the sphere x square plus y square plus z square equal to a square at the point x1, y1, z1 is this one. Here listen carefully. Right, I am taking the sphere S that equal to x square plus y square plus z square minus a square. Right, here S1. Right, S1 is nothing but x1 plus y1 plus z1 minus a square. S11, what is S11? x1 square plus y1 square plus z1 square minus a square. Right, this is the notations of S1 and S11. Therefore here listen, x into x1 plus y into y1 plus z into z1 minus a square. This is the notation of S1. Therefore S1, here square is there, S1 square equal to x square plus y square plus z square minus a square. It is a sphere equation I am taking. This is a S. Here x1 square plus y1 square plus z1 square minus a square. It is S11. Therefore enveloping cone formula is for any sphere, that is s1 square equal to s into s11. What is the formula? s1 square equal to s into s11. Now we go to the proof. Here listen carefully. Here see the diagram. It is a diagram. Carefully listen. Here this is a sphere, that is x square plus y square plus z square minus a square equal to 0, and it is clearly enveloping cone, and vertex is given, that is a p, x1 comma y1 comma z1. Here observe that the p point, the point P not on the surface. Clearly in the diagram we observe that the point is not on the surface. Therefore, the point is not satisfy the sphere equation. Therefore, I am writing here the sphere equation is x square plus y square plus z square minus a square equal to 0. Right? Point P, that is x1 comma y1 comma z1 is not on the sphere. Therefore, P x1 comma y1 comma z1 does not belongs to S. Does not belongs to is nothing but it not satisfy the sphere equation. Here I am writing here. Therefore, x1 square plus y1 square plus z1 square minus a square is not equal to 0. And here listen. I am taking another point on the sphere. That is a q x comma y comma z. Here observe that PQ is a tangent line. PQ is a tangent line. I am taking another point, that is the contact of the point, taking R, that is R. Here observe that R divides the line PQ in the ratio lambda is to 1. Why I am taking here lambda is to 1? Here listen carefully. Generally we take the ratio m is to n, but m value is not given and n value is not given. Therefore, m by n is nothing but some quantity, it has some value. I am taking the value is lambda. For example, 4 is to 2, 4 by 2, that is the value of 2. Therefore, here similarly, m is to n, we don't know about the values of m comma n, but I am taking the ratio m is to n. Therefore, m is to n is nothing but m by n. M by n it has some value. I am taking lambda. Therefore, m by lambda equal to n by 1. Therefore, now we have to the values, that is the lambda and 1. Therefore, I am taking the ratio lambda is to 1. Here understand? Right. Once again I repeat the proof of the theorem. S equal to x square plus y square plus z square minus a square equal to 0. P is not on the surface. Therefore, P is not satisfy the sphere equation. I am taking another point on the tangent line, that is a q x comma y comma z on the surface. Therefore, PQ is clearly tangent line. R be any point. The point R divides the PQ in the ratio lambda is to 1. Lambda is to 1. Here, what is the point? P x1 comma y1 comma z1 and q x comma y comma z. Ratio is lambda is to 1. Right? What is the formula? Ratio mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n, comma mz2 plus nz1 by m plus n. In the same manner, it is a value of m is to n, mx2. Therefore, lambda x plus nx1 1 into x1 1x1 by m plus n. M plus n is nothing but lambda plus 1. Therefore, we get the value of lambda x plus x1 by lambda plus 1, comma lambda y plus y1 by lambda plus 1, comma lambda z plus z1 by lambda plus 1, which is a point of the R which divides the tangent line in the ratio of lambda is to 1. Therefore, but here observe that point R, clearly point R on the surface. Therefore, the point R satisfy the sphere equation. Therefore, we put the values of r in sphere equation. Right? What is the value of r? Lambda x plus x1 by lambda plus 1, comma lambda y plus y1 by lambda plus 1, comma lambda z plus z1 by lambda plus 1. Therefore, what is the sphere equation? X square plus y square plus z square equal to a square. Now simplification this one. We get the values of lambda square of x square plus y square plus z square minus a square plus lambda into 2xx1 plus 2yy1 plus 2zz1 minus 2a square plus x1 square plus y1 square plus z1 square minus a square equal to 0. Here clearly which is yes, lambda square yes, plus 2 is common, therefore 2 lambda. What is the remaining? X into x1 plus y into y1 plus z into z1 minus a square, right, which is the notation of s1 plus x1 square plus y1 square plus z1 square minus a square equal to 0, which is S11. Clearly observe that it is a quadratic equation in lambda, but it is a tangent line. Therefore, the discriminant must be equal to 0. Right? What is the discriminant? B square minus 4ac equal to 0. Right? Comparing with this one, ax square plus bx plus c equal to 0. Therefore, what is a? Yes. Right? What is b? 2s1. What is c? s11. Therefore, b square minus 4ac equal to 0. Therefore, 2s1 square minus 4ac. A is nothing but s, c is nothing but s11. Therefore, 4s1 square equal to 4 into s into s11. 4 get cancelled. What is the remaining? s1 square equal to s into s11. Right, which is a proof of the above theorem. What is the main concept of this theorem? The enveloping cone formula is s1 square into s1 square equal to s into s11. Right. Next we go to the another definition. Right. What is a right circular cone? Right. Next definition is right circular cone. Right. Here listen carefully. A right circular cone is a surface which is generated by a line which passes through a fixed point and makes a constant angle with a fixed line through the fixed point. Here listen carefully. A right circular cone is a surface which is generated by a line which passes through a fixed point. Here important, by a line which passes through a fixed point and makes a constant angle with a fixed line through the fixed point. Here listen, it is a cone. A right circular cone is surface generated by a line which passes through a fixed point. It makes a constant angle. This one is called right circular cone. It is called semi-vertical angle. It is called axis line. Right. Here. Next we go to the here listen. Here the line is called axis and theta is called semi-vertical angle. Now we go to the theorem. Here listen carefully. What is a right circular cone? A right circular cone which is a surface is generated by a line which passes through a fixed point and makes a constant angle to the fixed line through the fixed points. Right? Next theorem, yes, it is a simple one. The equation of a right circular cone with vertex alpha, beta, gamma and semi-vertical angle theta and axis having the direction ratios L, M, N. Here listen carefully. Right? it is a cone, it is a not a right circular cone. When it forms a right circular cone, draw a straight line from a fixed point. It makes a constant angle to the fixed point and to the fixed line. Here it is theta, already in this given the angle is theta in the question, and I also is given the vertex, that is a P, alpha, beta, gamma, and also direction ratios of the axis line, that is a given L, M, N. Here observe that whenever possible to the angle, if two direction ratios is there, now we go to the direct formula, that equal to cos theta equal to L1 into L2 plus M1 into M2 plus N1 into L2 by under root of L1 square plus M1 square plus N1 square into L2 square plus M2 square plus N2 square. Here observe that clearly I have one direction ratio, that is L comma M comma N. Now we have another direction ratio. The direct formula is available. Put the values of in formula, then we get the required solution. But in this question we observe that the another direction ratio is not available. Right here clearly listen. I am taking any point on the line. That is x comma y comma z. Here observe that it is a point. It is also, I am taking the Q point. Here 2 points is there, that is alpha, beta, gamma and x comma y comma z. Whenever 2 points is there, we have the formula for the direction ratios, right? What is the formula? x1 comma y1 comma z1 and x2 comma y2 comma z2 are any 2 points, then the direction ratio is x2 minus x1 comma y2 minus y1 comma z2 minus z1. In the same manner we have to the 2 points, that is one of the point is alpha comma beta comma gamma and another point is x comma y comma z. Therefore the direction ratio is clearly x minus alpha, y minus beta comma z minus gamma. This is the direction ratios of another line. Here the first direction ratio is L comma M comma N and second direction ratio is x minus alpha, y minus beta comma z minus gamma. Now we substitute the two direction ratios in formula for the cos theta equal to L1 L2 plus M1 M2 plus N1 N2 by under root of L1 square plus M1 square plus N1 square into L2 square plus M2 square plus N2 square. Here listen carefully. Here the axis line, that is a capital L comma M comma N, and taking the vertex is given clearly in this question, that is alpha comma beta comma gamma. Now take a point on the fixed line, that is I am taking, that is x comma y comma z. Here that is x comma y comma z. Here p comma q is a 2 points, is a fixed line. Therefore but p alpha beta gamma and q x comma y comma z be any 2 points, then the direction ratios are x minus alpha comma y minus beta comma z minus gamma. Therefore cos theta equal to first direction ratios L comma M comma and second direction ratios is x minus alpha, y minus beta, z minus gamma. Now cos theta equal to L into x minus alpha plus M into y minus beta plus N into z minus gamma by under root of L square plus M square plus N square into under root of x minus alpha square plus y minus beta whole square plus z minus gamma whole square. Now squaring on both sides, therefore we get the values of cos square theta. The denominator square root get cancelled, remaining is L square plus M square plus N square into x minus alpha whole square plus y minus beta whole square plus z minus gamma whole square. Now cross multiplication, therefore L square plus M square plus N square into x minus alpha whole square plus y minus beta whole square plus z minus gamma whole square into cos square theta, that equal to L into x minus alpha plus M into y minus beta plus N into z minus gamma whole square. Right? Simply here listen. Simply x minus the point alpha by L equal to y minus beta by m equal to z minus gamma by n. It is a fixed line. Alpha gamma beta gamma gamma be the points and L comma M comma N are direction ratios. The formula is, listen carefully here, L into x minus alpha, L into x minus alpha plus M into y minus beta plus N into z minus gamma whole square equal to x minus alpha whole square plus y minus beta whole square plus z minus gamma whole square into L square plus M square plus N square into cos square theta. This is the formula for the right circular cone. Now we go to the problems. Here listen, the first problem is find the enveloping cone of the sphere x square plus y square plus z square plus 2x minus 2y equal to 2 with vertex 1 comma 1 comma 1. Now here just we remember the what is the formula for enveloping cone, right? What is the formula for enveloping cone? Right, s1 square equal to s into s double 1, right? First of all, it is given x square plus y square plus z square plus 2x minus 2y equal to 2. Here listen, s equal to x square plus y square plus z square plus 2x minus 2y minus 2 equal to 0. Right, what is s1? s1 is nothing but x into x1 plus y into y1 plus z into z1 half part. We can take half, that is a plus x plus x1 minus half, that is 2 by 2, that is nothing but 1, y plus y1 minus 2. The point is given 1 comma 1 comma 1. In place of x1 comma y1 comma z1 we substitute the values of 1 comma 1 comma 1. Then we get x into 1, that is x, plus y into 1, that is y, plus z into 1, that is z, plus x plus 1 minus y minus 1 minus 2 equal to 0. Now minus y plus y get cancelled, totally plus 2 minus 2 get cancelled. Now we get the value 2x plus z minus 2 equal to 0. Right, here what is s double 1? S double 1 is nothing but x1 square plus y1 square plus z1 square plus 2x1 minus 2y1 minus 2 equal to 0. But the point 1 comma 1 comma 1, now simplification this one, we get the values of 1. Therefore the formula for the enveloping cone is s1 square equal to s into s double 1. Now substitute these values s1 and s comma s double 1 in the formula of s1 square equal to s into s double 1. Then we get the required solution, that is a 3x square minus y square minus 10x plus 2y minus 4z plus 4xz plus 6 equal to 0. Right, here understand the formula. Just simply understand the concept of the enveloping cone and right circular cone. Whenever surface is given, whatever it may be, the formula is enveloping cone is s1 square equal to s into s double 1. Right, here listen, next question. Find the equation of a right circular cone whose vertex is 1 comma minus 2 comma minus 1 and axis line is also given, that is x minus 1 by 3 equal to y plus 2 by 4 plus equal to z plus 1 by 5 and semi vertical angle is also given, that is 60 degrees. Right, here what is the formula for the right circular cone? Simply here listen, whenever the axis line is given, just we have the formula 3 into x minus 1, 3 into x minus 1 plus 4 into y plus 2 plus 5 into z plus 1 whole square equal to x minus 1 whole square plus y plus 2 whole square plus z plus 1 whole square into 3 square plus 4 square plus 5 square into cos square 60. Right, now simplification this one, we get the values of answer. Right, is a required answer. It is a clearly formula, right? Now we go to the another problem. What is the problem? Find the equation of the right circular cone and axis line x equal to t, y equal to 2t, z equal to 3t, and whose semi-vertical angle is 60 degrees. Here clearly line is not given. Clearly line is not given, but we are observe that x equal to t, y equal to 2t, right? Here I am writing here y by 2 equal to some t, z equal to 3t, therefore z by 3 equal to t. These r values are same, it is t, it is t, it is t, therefore directly we can write x by 1 equal to y by 2 equal to z by 3. It is now clearly axis line is given. What is axis line? X by 1 equal to y by 2 equal to z by 3, right? What is the point? 0 comma 0 comma 0, right? Whenever in directly line equation is not given, x equal to something, y equal to something, z equal to something is given. Now simplification this one, then we get the value of line, right? Here x by 1 equal to y by 2 equal to z by 3 equal to t. Therefore clearly we can write x minus 0 by 1 equal to y minus 0 by 2 equal to z minus 0 by 3, that equal to t, right? Vertex is 0 comma 0 comma 0 and the direction ratios are 1 comma 2 comma 3 and theta is given, that is 60 degrees, right? Now simplification this one, we get the answer. Here another problem, interesting problem here. Find the equation to the right circular cone whose vertex is 2 minus 3 comma 5 and PQ which makes the equal angles with the axis and which passes through the point 1 comma minus 2 comma 3. Here whenever right circular cone asking the question, here must be given the angle, but in this question angle is semi-vertical angle is not given. First of all we have to find the semi-vertical angle. Here write clearly the line equation is x minus x1 by L, y minus y1 by M equal to z minus z1 by N, and x1 comma y1 comma z1 be point. In this case we have to define it is a vertex, right? And L comma M comma N are direction ratios. Here the vertex is given, that is a 2 comma minus 3 comma 5, that is therefore x minus 2 by L, y plus 3 by M, z minus 5 by N. But PQ makes the equal angle, therefore L equal to cos theta, M equal to cos theta, N equal to cos theta, equal angle. Therefore L comma M comma N equal to cos theta cos theta cos theta. Therefore simplification this one we have to 1 comma 1 comma 1. Therefore the direction ratios of 1 comma 1 comma 1. Therefore x minus 2 by 1, y plus 3 by 1, z minus 5 by 1. Now the right circular cone formula is 1 into x minus 2 plus 1 into y plus 3 plus 1 into z minus 5 whole square equal to 1 square plus 1 square plus 1 square into x minus 2 whole square plus y plus 3 whole square plus z minus 5 whole square into cos square theta. But the theta is not given, the condition is given, the above right circular cone is passes with a point 1 comma minus 2 comma 3. Therefore in place of x comma y comma z we have to put the values 1 comma minus 2 comma 3. Here listen, therefore cos square alpha equal to 2 by 9. 2 by 9. Therefore from equation number 2 we have to put the values of cos square theta, therefore that is a 2 by 9, and simplification this one, then we have to the solution. right? Thank you.